Hey guys, welcome to another video by Supernal Tutorials. In this video we're going to be looking at analytical geometry. This is our first video for analytical geometry. So in this question we're told that the circle is centered at M, right? This is M, and cuts the y-axis at E. This is point E, right? Yeah, this is point E right here, right? And we're told that the diameter CMD is drawn and ACB is a tangent to the circle. This information right here is very critical, and it's gonna assist us in answering the question, right? Okay, so let's go to our first question. We asked to determine the equation of the circle in the form, in this form right here, right? So looking at this equation right here, the first approach is to determine R. R is the radius, right? And at the information we're told that CMD is drawn. It's the diameter, right? So since we know that CMD is the diameter and we have the points for C and M, this gives us what? This gives us our radius, because we were told that M is the center from the statement, right? So we're going to calculate our radius using the points C and M, and to calculate it we're going to use the distance formula. We have point M, which is and then we also have point C. So we're going to use the distance formula to calculate our radius. X of M minus x of C squared plus y of M minus y of C. They can be in any order. You just need to make sure that you're consistent. If you're starting with C, start with C on both sides, right? Yeah. So when you substitute this, it's going to give us x of M, it's 2, right? Minus x of C, so it's minus 1, so it's going to be a positive 1 squared, plus y of M, it's 4, minus y of C, it's 2, so minus 2. So this gives us this is 3 cubed, that's 9, plus 2 cubed, that's 4. So this actually gives us root 13, right? So we have calculated the radius, but as you can see on the given standard form of the equation of a circle, it's written as root R, as R squared. So R squared will be the square of this. So R squared, if you square this, you want to put it to the power of 2. So this gives us what? 13. This comes from the fact that root A times root A is equals to A, right? This is laws of sets, I think. Yeah. So we have R squared, then we need to determine A and B. A and B, these are the center points, right? This is the X center point and Y center point. So this gives us our coordinates as given right here at the center point. So our equation will be as follows. As I've said, A and B, this is the center of the circle, right? So the center of the circle, it's M, right? So it's 2 and 4. We substitute these 2 points at A and B. So at A we substitute in our x coordinate, and at B we substitute in our y coordinate. So this is going to be x minus 2, right, squared, plus y minus 4 squared equals to what? R squared. Our R squared is 13. So this will be all for our first question. For our second question, we asked to write down the coordinates of D. As you can see, we have the point right here, M, and point C, and M is the center of the circle. So we can actually determine point D using the midpoint theorem, right? So the midpoint of what DC is point M. So I think it's represented in this way, yeah. Point M, yeah. So this is going to be midpoint of DC. This is x of D plus x of C over 2. And then for our y coordinate, it's going to be yd plus yc over 2, right? It's equals to what? M, which is our midpoint. This is 2, 4, right? So we're gonna we separate these parts. We equate the x coordinate to this x coordinate. We separate them. We also do the same for the y coordinates. So we're looking for x of D. This is going to be, I'm rearranging this fraction. So 2 times 2, that's actually 4, right? And then minus x of C, right? I'm sure you know how to work with the fractions, so I don't have to explain much right here. So this is going to be, right, x of C is -1, so minus 1, so this gives us 5, right? And then we're going to come this side to the y coordinate. 2 times 4, when we cancel it out, right, it's going to be times 2, then times 2. What you do on the left, you do on the right, so it's going to be 8, and then minus y of C. So 8 minus y of C. Y of C, it's 2. So this gives us yd is equals to 6. So coordinates of D are like this: 5, 6, right? You can also find the same answer if you apply inspection, right? So, but a method of inspection is whereby you actually just look at the diagram, right? So if you can check the diagram, right, this is what CM is a radius, in the same way that MD is a radius, right? So you check coordinate by coordinate, right? Let's check the x coordinate, for example, right? The x coordinate at C, it's what? It's -1, and then the x coordinate at M, it's 2. So to move from -1 to 2, you move by what? By 3 units, right? So it means that from C to M, you have to move to the right in terms of x by 3 units. So the same way, to move from M to D, it's 3 units. So moving from 2 to D, it's 3 units, which makes it what? 5. And then you also apply the same reasoning to get the y coordinate. You check the y coordinate at C, it's 2, right? And then to move from to move from 2, which is the y coordinate of C, to the y coordinate of M, which is what? 4. You move up by how many units? You move up by 2 units. So same way, we check at M. At M, it's 4 on the y coordinate. So since we moved here to there by 2 units in terms of y, then we're going to move from here to there by another 2 units to get the y of d. So this makes it what? 4 plus 2, which is what? 6. So that's how you do inspection. Yeah, but don't stress much about inspection because it might not always be obvious to do it. So you can always stick to formulas. Yeah, that's all for the second question. For our third question, we asked to determine the equation of AB in the form y is equals to mx plus c. This is the straight line equation, right? We asked to determine the straight line equation of this straight line. So as you know, to determine the equation of a straight line, we need m, which is the gradient, right? And we need another point on the straight line to actually determine point C, right? So as you can see right here, we only have the coordinates for point C, and there's no way you can determine the points A and B, right? So it means that solution lies somewhere right here in our circle, right? So as you can see, line MC, it's a line drawn from the center to AB. Remember, AB is a chord as is a tangent, right? As mentioned in the statement. So a line drawn from the center to a tangent is what? It's perpendicular. So these two lines are perpendicular to each other. MC is perpendicular to line AB, right? It means that the product of the gradient of MC multiplied by the gradient of AB, it's equals to -1. Yeah. So using this expression right here, we can actually determine the gradient of MAB, which is the line that we are interested in, right? Because we need to determine the equation of that line. So this is the expression we're going to use. So we need the gradient of MC. We can determine the gradient of MC since we have the coordinates, right? So as you can see, I've actually put this equation in terms of gradient of gradient of AB. So I can actually do this -1, right? And then but no, let me avoid adding confusions. So let me actually calculate the gradient of MC on the side. It's going to be easier this way. Y of M minus Y of C is equals to X of M minus X of C. I encourage the use of these variables instead of using y1 minus y2. It's better to use these ones because in this case you'll always know which coordinates or points you are referring to exactly. So y of m it's 4 minus y of c, it's 2, right, over x of m it's 2 minus x of c, so it's minus 1. So this is 2 over 3. So this is our gradient, right? And then to get the gradient of MAB, it's equals to -1 divided by 2 over 3. You don't have to stress much about this. You can actually put this in your calculator and you see that it's equals to -3 over 2, right? So we have the gradient, right? So we can actually take that equation and say it's equals to what? -3 over 2x plus c. We've substituted for m, right? Yeah, so this is how our equation is. And then now we need to substitute in a point on this line, right? A point on this line, it's c, right? Let's substitute in c to determine please don't be confused because we have a c right here and a point c on the graph. this C is just, it stands for constant, right? It's part of the equation of a straight line. Don't confuse it with this point C on this diagram. Okay, so when you substitute in point C right here, it's gonna be y coordinate, it's 2, right? Negative 3 over 2, and then you substitute in the x coordinate, that's negative 1 plus C. You use your calculator, you take this to the other side, you're going to find that C is equals to it is equals to let me take my calculator and actually check to be sure. If you put this in your calculator, you'll see that C is 1 over 2, so this is half, right? So therefore your equation of AB, it's going to be as follows, right? Plus C, which is what, half. So this is the equation of the straight line. To confirm this equation, well, in this case there's not much you can do to confirm it because you only have a point C, right? Yeah, so just ignore it. Yeah, okay, so yeah, this is the equation of the straight line for this question, right? Okay, so our fourth question, we asked to calculate the coordinate of E, right? Remember, in the first question we were asked to determine the equation of a circle. The equation of a circle represents the entire circle, so any point on the circle you can determine using that equation, right? So using the equation of a circle, we need at least 1 point. So as you can see, we were also told in the statement that E is a y-intercept, right? So it is right here on the x-axis, right? If you check right here on the x-axis, or any point on the on the y-axis, the x value is equals to what? 0. The x value is equals to 0 for any point lying on the y-axis. So we know that the x value of E is actually 0, right? So we're gonna actually use this information in the equation of a circle, and we're gonna get our value. This is the equation as calculated in question 1. So we're gonna substitute in the x value, which is 0. This is 4, right? So okay, this is 4, so I'm going to take it to the other side. It's going to be 13 minus 4, that gives us a 9, right? And then we're going to apply a square root, right? When you apply a square root, the 2 power cancels right there, and then applying a square root on 9. Please always remember that when you apply a square root, it does not necessarily give you a positive answer. A square root occurs in 2 parts, which is a positive and a negative. So it's a positive or a negative 3. Always remember that. Yeah, so this is going to give us 2 solutions, and I'm going to explain why we even have 2 solutions in this case. Excuse me, this is going to be y minus 4 is equals to negative 3. Okay, so checking this, is going to be 3 plus 4, so it's a 7, or negative 1, right? Okay, so checking these 2 values, when you reason, you can actually see that on the circle right here, right, we have 2 y-intercepts, which is points where x is equals to 0. At this point right here on the circle, x is equals to 0. So if you apply logic, you can actually see, actually this is a positive 1, because negative 3 plus 1, yeah, it's a positive 1. Sorry for that. So as you can see right here on the diagram, right, we have two y-intercepts. So clearly the high E is at a higher point, so logically y is equals to 7 is the correct answer, right? So E will be 0, 7, right? And then this y value will be for the point right there at the bottom, right? Yeah, that will be all for this question. For our fifth question, we asked to show that EM is parallel to AB. EM. So let me make a construction and just put it like this. EM, right? We need to show that EM is parallel to AB. To show that two lines are parallel, they need to have the same gradient. So from the third question here, we actually determined that the gradient of line AB, so the gradient of AB is actually negative 3 over 2. Yeah, from the third question, this was our conclusion for the gradient of AB, right? So we need to show that EM has the same gradient, therefore it will mean that these two lines are parallel. So yeah, let's calculate the gradient of EM. We have those 2 points, right? So y of E minus y of M over x of E minus x of M. So this is going to be y of E, that's 7, minus y of M, that's 4, over x of E, that's 0, minus x of M, that's 2. So this is what please be careful right here, it's going to be a negative 2 at the bottom, right? So this gives us a negative 3 over 2. So as you can see, the gradient of EM is equals to the gradient of AB. Therefore, EM is parallel to AB. AB. Yeah, that's all for the fifth question. For our sixth question, we actually asked to determine whether or not the circles having equations x plus 2 squared plus y minus 4 squared is equals to 25 and x minus 5 squared plus y plus 1 squared is equals to 9. So we asked to determine whether the two circles will intersect, right? Firstly, these two questions are not this question is not related to the previous questions, right? As you can see that these equations are all different from the one we had determined in the first question. So a lot of textbooks actually make this concept of intersection to sound a lot theoretical, but we can actually put it in calculation and actually determine this intersection, right? So we're gonna approach this in 2 steps, right? We first need to determine the centers of these two equations, right? These two circles. So we're gonna start with this circle, right? So the center of this circle, it's gonna be like this, right? When we extract points from the equation of a circle, we oppose the sign, right? So this 2 is going to be a negative 2, right? And then this negative 4, it's going to be what? It's going to be a 4. All right. Call this T, right? And then we come to this other circle. We extract the center point. Call it point U, right? We oppose the sign. That's going to be 5. And then plus 1, it's going to be what? A negative 1. We're opposing the sign. Okay, so these are our two centers of these two circles, right? So to determine intersection, we need to make 2 calculations. The first calculation, we determine the length of TU just substitute in directly. X of t, that's -2, minus x of u, so it's -5, plus y of t, that's 4, minus y of u, that's -1. If you put this in the calculator, it's gonna give you root 74, and then you need to put this in decimal form when you're dealing with intersection, and you soon realize why. This is approximately 8.6 units, right? And then I said we're gonna do it in 2 steps, right? So the first step, you determine the length of the 2 centers, right? Which is what the distance between the 2 centers. I mean, yeah, this is TU, which is the distance between the 2 centers, right? And then the second step, you determine the distance between the circle radiuses, right? And as you can see from the given equation, these right here, these are considered what? R squared from the standard equation, right? So R squared 25, just call it maybe RT. Yeah, we're gonna relate it to the center, which we call T, right? So it means that RT is gonna be what? 5. When you put what? A square root, and then call the other one RU squared, it's what? 9. When you put a square root, it's gonna be RU is equals to 3. Remember, this is a length and a radius, so we will only consider the positive part, because this is a radius, which is a length. We cannot have a negative length. Okay, so yeah, and then we add the radiuses, so it's going to be 5 plus 3, which is what? 8. Okay, so we have made those 2 calculations, right? So we compare these 2 calculations, right? So to determine whether they will intersect, there are actually 3 conditions. There's a condition which says they intersect at 1 point, and then the second one, it says they intersect at 2 points, and then the last one, it says they do not intersect at all, right? Okay, so since we've made the two calculations, right? So this was the distance between the 2 centers, and this is the sum of the radiuses of the 2 circles. So it's like this, say RT plus RU, right? We compare, right? So if RT plus RU is equals to what? The distance between the 2 centers, which is TU, right? Then it means that they intersect at 1 point, right? And then if RT plus RU is what? Is greater, right, than the distance between them, right? It means that they intersect at 2 points. And then if RT plus RU is what? Is less than TU, they do not, it means that they don't intersect, right? So we go back to the two calculations we made. TU for the distance between the two centers, and RT plus RU, which is the sum of the radiuses. Okay, so as you can see, the sum of the radiuses is 8. So we have 8 right on the left hand side, and then we have what, the distance between them, which is 8.6. so as you can see, 8 is less than 8.6, meaning that they don't intersect. For this question, you don't even need to have the actual diagrams to actually determine the intersection. You just need to know these 3 conditions. But of course it helps to know how it looks when they intersect. You can actually reference that from your textbook. So this will be all for analytical geometry video 1. Thanks for watching, and please share with your friends.